Hello, welcome to lesson 7 on the topic time and work. If you remember, in the last lesson we were discussing the concept of alternate work. To remind you, in every problem of alternate work, we need to take the 1 day's work of everyone, find out the total work of one cycle, and then proceed with the problem. What I want to share with you that the concept of alternate work can be combined with other conditions in a problem. Let me share by taking an example. So, please look at this example carefully. A can complete a task in 12 days, B can do it in 24 days, and C can do it in 48 days. So A can do it in 12 days, B can do it in 24 days, and C can do it in 48 days. Alright? Now what is the question? The question is, A is helped by B on the first day and A is helped by C on the second day. So A is helped by B and C, one each on every alternate day. Okay? A is helped by B and C, one person each on every alternate day. So you must have understood by now, the question is a combination of alternate and one more additional condition. How do we proceed? What we'll do is we will first consider the total work done as 48 units. This would lead us to A's efficiency as 4 units, B's efficiency being 2 units, and C's efficiency being 1 unit. Alright? Now we will take it exactly as we would do in a question of alternate work. So who is working on the first day? A plus B. How much work they will do? 4 plus 2, which is 6 units. Who is going to work on the second day? A is going to be helped by C. So what is the work done? 4 plus 1, which is how much? 5 units. Now as per the problem, this completes one cycle. So we can stop here. And what we'll do? We'll say 11 units in 2 days. Alright? I hope this is absolutely clear to all of us. So total 11 units in 2 days. Remember, you cannot take the average. So you cannot say 5.5 units per day, but you can definitely say 11 units in 2 days. What is the next thing that we are supposed to do? Go to a multiple of 11 closest to 48. Don't cross 48. Alright, so 11 units in 2 days, therefore 44 units. That means we are talking about 4 cycles. We are talking about 4 cycles. So 44 units in how many days? 44 units will get completed in 8 days. Alright. Which combination is going to work on the 9th day? A plus B, because they have started it. So on the 9th day, A plus B is going to work. 44 units is already completed. How much they will be able to do in one complete day? 6 units. But what is the remaining work? It is only 4 units. So the remaining work, that is 4 units, and therefore 48 units will be completed in 8 4 by 6 days. Okay, 8 4 by 6 days. Once again, 4 units are remaining. They are able to do 6 units every day, so they will not take the entire day. They will be able to complete it in 4 by 6 days. Please do remember to convert it into the smallest form. So how much time it will take for the work to be completed? The work would be completed in 8 2 by 3 days. Now children, what was why did we take this example? We took this example primarily to share with you that the concept of alternate work can always be combined with some other additional condition and then converted into a problem. If the concept is clear, I should not have any difficulty in answering the question. Okay, so that was the concept of alternate work. Alright, so now we will go to the next concept that we have to learn in this topic. If you remember, so far in this topic of time and work, we have always been talking about positive efficiency. Now for the first time, we are going to get introduced to negative efficiency. And for your convenience, it could happen with people, but for your convenience, this happens to be a popular category of problems that are asked in competitive exams, and this is called as pipes and cisterns. A pipe is obviously a pipe which fills water, and a cistern is nothing but a huge storage vessel which stores water. Alright, so let us look at the questions of this in this concept, right? Pipes and cisterns. Let me begin by taking a very basic example. Alright, a pipe can fill a tank in 30 hours. A pipe can fill a tank in 30 hours, whereas a leak can empty the tank. This is a leak. This represents a leak. L will represent a leak. P represents a pipe. A pipe can fill a tank alone in 30 hours, whereas a leak can empty the tank alone in 50 hours. Okay, so what is the question? If both the pipe and the leak are opened, in how much time is the tank going to get filled? Alright, in how much time, what is the time taken for the tank to get filled? Okay, now the basis or the approach is going to be same as what we have been discussing so far. So what we will do, the first thing that we will do is take this as 150 units. And therefore, we will say that the pipe is able to fill 5 units. The pipe is able to fill 5 units per hour. The leak is able to empty 3 units per hour. See children, you can either write down empty, or I have another suggestion. If you don't want to write empty, you change the sign to -3. Alright? What is the only change that you are talking about here? So far, in all the questions that we have done, we would say that the total work done would be 8 units, but now it is not 8 units because the efficiency of the leak is in the opposite direction. I hope you are understanding. So, the pipe is able to fill 5 units, the leak is able to empty 3 units. So 5 minus 3, effectively we are talking about 2 units being filled per hour. Alright, now what is the question? In how much time can the pipe and leak together fill this tank? To fill the tank, how much I have to fill? I have to fill 150 units. How much do they fill per hour? 2 units. After adjusting for the water that flows out because of the leak or gets drained out because of the leak. So 2 units per hour is the water that is getting filled. Therefore 150 units can be filled in 75 hours. Alright, a very simple example to begin with. The only change that you have to deal with or you are talking about is taking the sign. If an entity is working opposite to the work being done, then its efficiency has to be taken with the negative sign. Alright, okay. And I hope you are also able to understand that if in the same question I would have asked you that the tank is full, or maybe the tank is half full, the tank is full or the tank is half full, and both of them are opened, in how much time will the tank become empty? Then your answer should have been, it is not possible. Okay, if the tank has even a little bit of water, This is very interesting. Please listen carefully. If the tank has even a little bit of water, maybe even 10% or 20%, from there, if both of them are operating, it is not possible to empty the tank. And why it is not possible? Because the efficiency of the entity which is filling the tank is more than the efficiency which is emptying the tank. So water effectively can never flow out of this tank. It can only get filled under this condition. Okay. Now, can I add some other condition to this same problem and change it? Yes, you can add some conditions to the same problem and convert it into a different problem. So let us take that example also. Maybe we'll take the same data, but try and change the question. Okay. I hope all of you are listening. So example 2. Pipe 1 can fill it in 30 hours. Pipe 2 can fill it in 50 hours. And leak can empty the tank in 100 hours. Okay. For convenience, what I am doing is I am representing this within a bracket. So this is for my own indication that the leak is working opposite to the pipe 1 and pipe 2. Okay. So P1 30 hours, P2 50 hours, and the leak is able to empty the tank in 100 hours. So what is the question? For the first 2 hours, P1 and P2 both are working. After 2 hours, P1 is closed. At the end of the 6th hour, P2 is also closed. And leak is opened. Okay, I hope you are understanding the question. We'll take maybe another minute and a half or 2 minutes to finish this discussion. So first 2 hours P1 and P2 are working. After 2 hours P1 is closed. At the end of the 6th hour P2 is also closed and the leak is opened. After how much time from the start? Will the tank be empty again? Oh, this is interesting. After how much time from the start will the tank become empty again? Okay, so let's do one thing. Let me write it a little bit towards this side. So P1 was 30 hours, P2 was 50 hours, and the leak was 100 hours. Very simple. Okay, so what we'll do, we'll take this as 300 units. So this is 10 units, this is 6 units, this is minus 3 units. Okay, now what is happening for the first 2 hours? For the first 2 hours you have P1 plus P2 both working. After 2 hours P1 is closed, and at the end of 6th hour P2 is closed. So for the next 4 hours only P2 is working. Now please appreciate, at the end of 6 hours so much of water is filled in the tank. So how much water is filled in the tank? 2 into what is P1 plus P2? 10 plus 6 plus 4 into what is P2? 6. So this is 16 into 2, this is 32, plus this is 24. Therefore, now please appreciate, this is very important to understand. At the end of the 6th hour, the tank has got 56 units of water. Sometimes as a student, I suddenly get confused that the total capacity was 300 units. Let the total capacity be 300 units, but in that 300 unit tank, the total volume of water that has been filled is 56 units. Now, who has to empty the tank? The leak alone has to do it. How much water it has to drain out? It has to obviously drain out 56 units. So, therefore, what will be the time taken? The time taken will be 56 by 3. 56 by 3 can be written as 18 2 by 3 hours. I hope this is correct. 18 2 by 3 hours. Okay. So, what was the question? Let's come back to the question. After how much time from the start will the tank become empty again? So children, the first 2 hours, the next 4 hours, and finally 18, 2 by 3, 18, 2 by 3 hours. How do you add this? 18 plus 2, 20, and 4, 24. So 24, 2 by 3 hours. After 24, 2 by 3 hours, the tank is going to become empty again. In the next lesson, we will discuss some more examples of this and look at some typical questions. Thank you.